Swayam Prabha. Digital India. Educated India.
So, friends, in the course on production and operations management, we are talking about JIT manufacturing strategy, which has the objective of zero inventory. So, in that we have said that in JIT we are doing the activity only when it is required, and for that purpose we organize the work. We organize the work in such a manner so that I can produce the smallest possible quantity, smallest required quantity at latest possible time, and for that I am building the smooth and rapid flow of processes, rapid flow of material by organizing my work in such a manner, organizing the workstation in such a manner, so that I am having a smooth and rapid flow of material right from raw material to finished goods. The material entered into the factory till the finished goods leave the factory. So, now we are talking about what all, then we also talked about the various types of waste. Waste in JIT, we said overproduction is a waste, we said keeping inventory material is a waste, transportation is a waste, and so many such kind of waste we have identified. All types of delays is also a waste. Now, here moving forward from that, we will see that what are the various building blocks for achieving the goals of JIT. The goal of JIT is, as I said, a balanced rapid flow, smooth and rapid flow, that is my ultimate goal, smooth and rapid flow of material from entry of the raw material to exit of the finished goods. So, what is required for that? Let us focus from the building blocks. So, building block, first important building block is product design. My design should be modular in nature, my design should be having all aspects which we have studied in product design. When we say product design, so we talk about modularity, so that I can create the variety with the minimum of inventory. Then there should be standardization, the parts and components, if I am able to standardize, that will also help in variety reduction and the requirement of inventory also. The advantage of modularity is I can create variety, without keeping the inventory of finished goods. So, that is important as far as product design is concerned. Then come the process design. What type of processes are required in JIT environment? We are not keeping inventory, all our response will come through the process. So, process become very important in JIT manufacturing to reduce the inventories. We are giving the response not through the inventory, rather through the processes. So, my processes should be flexible. I can change, I can use them for any purpose. This flexibility, so the flexible processes is very important requirement. Flexi is with respect to volumes. I can increase or decrease the production rates. It can be with respect to product mix also. I can produce A, B and C of 100 each also, and if required I can produce 50 of this, 120 of this, 120 of this also. So, that kind of flexibility I should have, and in the processes there is also the routing flexibility should also be there. If one machine is not working or there is overload, I can route it through some other process also. There are several other types of flexibilities are there, but in this unit of JIT we may take that volume flexibility, mix flexibility, routing flexibility, they are the important process flexibilities which should be there in the our processes should be computerized control or CNC computerized numerical controlled machine are the best technologies for that. And then also we need to have automation. flexible automation also where possible, so that we can reduce the cost also. The automation need to be a flexible automation. Then come the personal element, what type of human resource we need, what type of human resource we need. So, for as far as human resource is concerned, human resource personal element, we need multi-skilled persons. The important requirement here is multi-skilled person. So, that I can change the production rate, we will see one example immediately after this. So that we can change the production rate by rearranging the work. So, that is the advantage of multi-skilling. In JIT context, we say that if the worker is working at a particular workstation, he must know the job of previous 2 workstation, he also must know the job of next 2 workstations also. So, that kind of a skilling is required in JIT context. Then manufacturing planning, what type of the fourth element, fourth building block is related to planning. My production planning should be very flexible, and my production planning should be flexible. It is done through Kanban system. It is done through Kanban system. So, we will study that. So, these are the 4 building blocks for JIT. If we are having these 4 in place, I can eliminate the disruptions, and I can make the system flexible and eliminate the waste also. If all these things are done, I will have a smooth and rapid flow of material in the shop, in my processes. So, that is how we are going to work out on this. Now, we are talking about the Kanban system. Before understanding the nitty-gritty of Kanban system, let us understand what is meant by push system and the pull system. In the push system, we have a forecast from the customer, demand forecast. Based on the forecast, we place the order to the supplier, and then as the supplier is ready with the material, he will supply to the factory. Once the factory has produced, it will give to the market. So, there may be a case that between the forecast and the actually when material is reaching there is change in requirements, and that is the main reason, that is the main disadvantage of a push system. And this is especially true when you are producing high variety. When you are dealing with high variety, there may be a case that by the time between forecast and the actual material coming to the customer market, there may be a change in the requirement. If you are dealing with only one type of a product, then this is the best, push system is the best method. So, prior to 90s when we were having very limited variety, push system was the best system, inventory based system were the best systems to follow. But as the variety has increased and new products are launched very quickly, new products are launched very fast, every 3 months you are launching a new model or something. In that context, push system is not a very efficient system. Then let us see what is the opposite or alternative to this. Alternative is pull system. Pull system, we are not what we are doing is, whenever there is a demand from the customer, then only we do the assembly, and for doing the assembly we fabricate the part. For fabricating the part, we go to the supplier and purchase the part. That is the ideal kind of a situation which I am considering, but still we keep certain components here, and but major trigger to produce will come through the customer side, whereas in the push system the trigger to produce will come through the material side, from the supplier side. If supplier has given you the material, you keep on producing it, but here the information flow, if you look at the blue color line is the information flow. Information to produce is coming from the customer side in the pull system, whereas information to produce in push system is coming from the supplier side. So, that is the important difference. The material flow is same in both the cases, material has to flow from supplier to customer, but information flow, who is providing you the trigger to produce, in pull system it is coming from the customer side, in the push system it is coming from the supplier side. So, pull system, system for moving the work where a workstation pulls output from the preceding workstation. So, this workstation pulls the production from the preceding workstation as needed. So, Kanban system. Push system, system for moving the work where output is pushed to the next workstation as it is completed. You have completed the work, you are pushing the material to the next workstation, whereas in this case material is pulled by the customer. Now, coming to the very popular Kanban system, many a times we say JIT system means Kanban system, though the JIT is a much bigger concept and in which Kanban is one tool to achieve the planning aspect. Kanban system is a planning tool. We said that planning is also important for rapid and smooth flow. So, it is a planning tool, planning activity where Kanban is used. It is a pull system where the customer side pulls the material from the previous preceding stages. To understand this diagram, let us understand first two types of Kanban cards. One is called move Kanban, first type is called move Kanban, second is called production Kanban. So, I am showing green color cards as the move Kanban. They move the material from one workstation to another workstation, where from one workstation to another they move the material. Then there is a production Kanban which moves within the workstation, which trigger the production of a component or a part or a final product. So, production Kanban give the trigger to produce a particular item at a given workstation, move Kanban give a trigger to move the material from one workstation to the next workstation. And then there are two more symbols we are using, where this there is no dot in between and there is a dot. Dot means material. If there is a card with the dot, that means this card is attached to the material trolley or material bin or some rack or something like that. Okay. Having said that, so let us understand what is Kanban system. So, in Kanban system, the material flow is, as you can observe, the material is flowing from lower side to the upper side of this diagram. So, the material flow is in this direction. Okay. So, this is the workstation which is close to the customer, customer is on this side and supplier is on this side, okay, and material is flowing from supplier to customer side. So, I have given this is the stage n, where which we will understand production stage n. There is a stage next to it, that is n plus 1, and there is a several stages prior to that also. Let us understand, let us say this is my assembly area and this is my final customer area, dispatch area. Let us say you are producing three types of products, red, simplicity say A, B and C. You are producing three types of products A, B and C in this plant and just selling it. And let us say you have kept 5 units of A here, 5 units of B here and 5 units of C here. When I say 5 units can be individual units, it can be 5 packets, it can be 5 some packing which you have kept here. Okay. Now, suppose there is a customer coming from outside and he demand component B, he demand 1 unit of component B. What will happen? You give the component to him, the blue dot which is representing the material, it will go to the customer and the empty card is kept here and the empty card is kept here and it is kept at the Kanban post, just like a letter box, we can keep that physical card. Before that, let us understand what is this card. This card is a just like our visiting card kept in a plastic packet, a jacket, and on this you are written the part name, part number, part name, and if it is a move Kanban between the two workstation, from which workstation to which vertical workstation it is going to that, and then it is also written the quantity. How much quantity is there with each Kanban card. Here we are presuming there is one container, one packet is attached with the card. Okay. Now, once you have sold this, empty card is kept here, empty Kanban is kept here. Once a Kanban card is here, this becomes a trigger for the worker that material is required. So, he will pick the Kanban card from this place, will bring it to the here, he will bring it to card will bring he will come here and he will take out this material which is lying with the red card. He will take out this material and will go back to there and replenish the material here. He will replenish the material here. So, once the material is taken by this and moved to the here to replenish it, this red card will become empty without material. Material is taken by the to the next workstation. Once the material is taken to the next workstation, the red card Kanban is kept here. Once this card is here, this become a trigger for this worker that he has to produce. And what he has to produce? This card is of B type. So, he has to produce a product, he has to assemble a product of B model. So, he will start assembling the model B here. To assemble it, the component and parts are taken from the inbound store and he will assemble and replenish it here. Once he is taking the components here, this card become empty and this is kept here. Once the card is here, this becomes a trigger for the worker to move the material from this place to, again this empty card is kept here and person will come, he will pick the material and he will replenish it back here. So, this is how a trigger which is created at the customer place is moving to the different workstation. Once you are taken the material from this place, this becomes a trigger for the this workstation to produce something. So, the same duplicate we can do that. So, this is a workstation, this becomes a trigger for him to produce components and part, fabricate the component parts which are required for product B. So, like this, a trigger created at the customer end will flow throughout the organization, throughout the manufacturing facility and even going to the purchase also and going to the vendor also. So, if there is a demand of B, whole of your factory is working on the product B and B type of components are purchased from the vendor also. Now, you will find here, you will observe here the inventory, I am not saying 0 inventory we are keeping. If we have planned 5 units here, then in under no circumstances there will be more than 5 units here. So, that is what the control which has come on the inventory, under no circumstances there will be more than 5 packets of A, B and C here. So, in subsequent stage you may reduce from 5 to 3 and so on, that is the improvement you can bring depending upon your improvement in the processes. So, what we have seen here in the Kanban system, you can the learning is number 1, the trigger created as a customer is moving throughout the manufacturing facility and even moving to the suppliers also. Whatsoever item is demanded by the customer, same item is getting manufactured in the assembled, fabricated, purchased in the organization. Number 3, we are keeping certain limited quantity at each of these stage and in no circumstances this quantity is going to exceed, because you will produce only when there is a trigger, when there is a card available, and card will be available only when some item is sold, some item is taken by the next stage in the manufacturing process. So, this is how we can see this as a pull system, a Kanban system, very important system. So, you can see here such a simple system we have in place for the purpose of planning. So, whole of the planning you need not to require any software or anything, whole planning is done with the help of that simple Kanban system. But we have to keep in mind as a caution, we should not be getting one sided. Pull system is good for the short term shop floor planning, but obviously you have to do the forecast also for the purpose of long range planning. You have to give orders to your suppliers, you have to keep the manpower ready, you have to keep the processes and capacity ready. For that purpose you need the forecast also, and in a way we can say this is a hybrid system. We are keeping certain inventory and other responses are coming through the process. So, most of the system we can say it is a hybrid, where we are keeping a certain amount of inventory and then we are doing all our planning and inventory management with the help of a pull system, with the help of a Kanban system. Now, let us see how to determine the number of Kanbans. We can set up a Kanban system requires determining the number of Kanbans required, whether 5 cards to be kept, 5 like in the previous example we have said that 5 cards of each of product A, B and C we are keeping there. So, whether 5 to be kept or 50 to be kept or 20 to be kept, that will depends upon what is the lead time, how much time it takes to replenish the material, to manufacture the material. For that we will keep the, or what type of safety stock is required, that is there. So, each container represents the minimum production size. So, we said that one container, and accurate estimate the lead time is required. So, here also lead time is required. There is some time gap between when the material is demanded. We find a card here, red card is here, and like here we have said that card is here. When the card is here, how much time it take to replenish when the material is moved from this place to this place, how much time it take to manufacture and replenish the material here. So, that is called lead time, or there may be, if the workstations are far away, there may be some time taken to suppose it is a marketing example, this is your manufacturing. So, how much time is required to take the material from factory to the wholesaler, wholesaler to the retailers. So, that way also we have to look at the lead time. We have to also look at the lead time of manufacturing and lead time of purchasing also. So, all types of lead time, whether it is a purchasing lead time, manufacturing lead time or distribution lead time, all we have to keep in mind while deciding how many Kanbans, how much quantity I should keep at a particular place. So, let us use this formula, very simple formula. Now, we are aware in the inventory also we were using K is the number of Kanban card sets, D is the average number of units demanded. So, demand rate, L is the lead time to replenish the order, and S is the safety stock expressed as a percentage, and C is the container size. So, expected demand during lead time plus safety stock is the total quantity required, and if each container has certain size. So, based on that we can decide the number of Kanban card required. So, K is the number of Kanban card required. Let us see one example. Let the average number of unit demanded over a given period of time is 20 units per hour. The demand is 20 units per hour, lead time is 4 hours. So, we are talking basically manufacturing between we are talking the 2 manufacturing stages within the factory, 2 manufacturing stages within the factory. So, 4 hours is the time required to replenish the material, safety stock requirement is 20% and container size is 10 units. So, what we are getting is D is 20 into lead time is 4 hours and we are keeping 10% 20% of safety stock, and my container size is 10 units. So, for this sorry, there is a mistake here, we are saying safety stock is 20%. So, we have to correct it here. So, from this we can do 2080 into 1.2, 96 is my this divided by 10. So, 9.6 containers, 9.6 Kanban is coming, which we can round off. 10 Kanbans are required for this particular work. So, this is how we can do that. So, we can calculate the number of Kanbans with the help of this formula, that is K is equal to D into L multiplied by safety stock and divided by the container size. Let us see one example here. Let us say there is a demand of 20 units per hour and lead time to replenish is 4 hours. We are taking a example of a manufacturing. We are taking manufacturing example where between 2 workstations we are talking about, just like in our Kanban system we were saying this is one workstation, this is another workstation. So, material has been consumed here. So, how much time it take to replenish? So, that is 4 hours, and safety stock we are talking about 20% and container size is 10 unit. So, number of Kanban required is D is 20 units per hour, lead time is 4 hours, safety stock is 20% and divided by container size 10. So, this is 9.6 which is equivalent to 10. So, I need to have 10 Kanban cards here for this particular situation. Between these 2 workstation I have to keep 10 Kanban cards here, and as and when. So, 10 Kanbans are kept here. So, between workstation n minus 1 and n, material flow is in this direction. So, this is how we can calculate the number of Kanbans required. Now, let us see the advantage of multifunctional workers. We said that we should have workers of multifunctional nature. This is assembly area where the cycle time is 1 minute per unit, that means 60 units per hour is the production rate required. Okay? And we are using 8 workers to do this assembly, and this circle shows that this is worker number 1, this is 2, this is 3, 4, 5, 6, 7 and 8. 8 workers are deployed to do this assembly task and certain elements are allocated to them. Suppose there is a reduction in the requirement from the customer. In the market the demand has reduced and then we are having options. One is keep on producing 60 units per hour and build up the inventory, build the inventory. Second option is use 8 workers and reduce the output. Third option is reduce the workers and reduce the output also. And this worker which you are reducing, they can be used for some other purpose. They may be painting of the pipes or learning new skills. You are not laying them off, but they can be deployed at some other place. There may be high demand in some certain areas. So, suppose now production rate has reduced from 1 minute per unit to 1.2 minutes per unit, that means 48 units per hour and we need only 6 workers. So, I can continue with 8 workers as I said in the previous slide or I reduce to 6 workers. So, this is how the deployment is now. So, same assembly task, same elements which I am doing with 8 workers, by redistribution of my assembly work, now I am performing the same task with 6 workers. But this is possible only earlier these elements were done by the worker number 2. Now, worker number 1 is doing it. That means, my worker number 1 should have the skills to perform these elements. Similarly, there is a redistribution of element to work station 2 also. So, I need the worker to be multi skilled, then only this kind of a approach is possible. Third important tool, I am just giving you a glimpses of certain tools which we are using for the purpose of producing the product just in time to be required by the next workstation. Third is that we can study the spoke system and the rim system of delivery. Suppose this is your manufacturing plant and you are having vendors, suppliers. Let us say you are having 1, 2, 3 like this 10 suppliers you are having for this item. Okay. For this manufacturing one set of suppliers, there are 10 suppliers you are having for your factory. In a traditional way, in a spoke system, each supplier is supplying you a truckload of material and one truckload is let us make some assumption, one truckload is equivalent to 10 days of requirement, 10 days of requirement. Okay. So, one truck is coming with 10 days of material. So, 10 trucks are coming bringing 10 days of material, then truck is coming on 1st of every month, 11th of every month, 21st of every month and then again 1st of every month. So, 3 times a month trucks are coming. So, the total number of movements are factory is receiving 30 trucks per month. They are receiving, the plant is receiving 30 trucks per month and each carrying 10 days of material, each carrying 10 days of material. So, my average inventory is of 5 days. Okay. Now, let us see the rim system of delivery. In the rim system, rather than each supplier is supplying independently, a truck is starting from the plant and it goes to all the vendors, collect the material from all the vendor and return back here. And every day one truck is going and collecting the material from all the 10 vendors and returning back here. So, how many trips in a month? 30 trips, 30 trucks per month. Every day one truck. So, on average on every month we are consuming 30 trucks per month. How much material this truck is bringing? 1 day of material, 1 day of material of each component from each supplier, 1 day of material from each supplier. So, average inventory is 0.5 days. So, with same 30 number of trucks, I am able to reduce the inventory from 5 days to 0.5 days. There may be small increase in transportation cost, small increase in transportation cost. because when they are coming from point to point, the transportation cost may be less. He may say that suppose here for example sake, each truck is costing let us say 5,000 rupees, 5,000 per truck per trip. Here he say that okay, 5,000 plus rupees 100 per stop, rupees 100 per stop. So, he is stopping at 10 different places. So, the truck cost may be rupees 6,000 per trip. So, there may be small increase in transportation cost, but a substantial reduction in inventory cost. Not only that, not only the reduction in the inventory cost. Now, this system is more flexible. If there is a change in the production plan, you will be able to bring the change only after 10 days, because the next consignment will come after 10 days. If there is a change in the model or change in the product mix, that can be implemented only after 10 days. But in this case, it can be implemented very next day also. You can give a new production schedule to your suppliers, and accordingly material can reach to the factory. So, this RIM system of delivery provides you the flexibility also, reduction in the inventory also, at the cost of small increase in transportation. Let us see the purchasing, JIT purchasing if we are talking about. In the traditional purchasing, we are having multiple sources, and we are always doing the bargaining with the suppliers. So, relations are adversarial, that means if one person is winning, another person is losing something, and purchases are short term, transaction to transaction, one consignment to one another consignment, and there is no openness. We are not sharing our information, we are bargaining with him, and information is the strength we consider in bargaining. We do the negotiations also, and we issue the purchase orders, and in that maybe prices are high and infrequent large lots we purchase. We take the quantity discounts also and purchase in large quantities also, and we are receiving the material in the warehouse. Material is delivered to the warehouse. Whereas, in the JIT purchasing, if we look at JIT purchasing, we are having only one or two suppliers, maximum two suppliers in JIT for a particular item, and these suppliers are nearby also. So, that you can get multiple deliveries in a day, and there is a strategic partnership between the buyer and the seller. So, between vendor and the OEM, there is a strategic partnership, that means you are having a long term relation, and many a times there is a investment also of the OEM in the vendor also. You have your financial investments also, as well as your knowledge investments also in that, or maybe one of the member of OEM buyer is on the board of vendor. On the board of management, you are having one representative there also at the vendor place, because you are having the financial stakes also in your vendor. And then you are having long term stable relationships by on site audits and visits, and material will come to the point of use. If the material has to come from point of use to avoid the multiple transportations and other things, so in that case it will come at the point of use. So, so for that purpose the quality should be very good, vendor certified quality, or quality is audited at the plant level, at the vendor level itself, and there are exclusive contracts also. Prices are low because you are placing the order in large quantity. On 1st of January, you are placing the order for complete year, and then you are asking for frequent and small deliveries. One order is placed for every year, and deliveries are given, schedule is given, 1 month schedule is given, which is temporary, then 1 week schedule is given, which is slightly more robust, and then weekly schedule, daily schedules are also given to the vendor, and then the delivery point of use and self certification is done by the vendor. So, this is how this JIT purchasing helps in reducing the inventory of bought out components and parts. Now, as I said, 5S policy for housekeeping, very important concept. This is actually, we call it foundation techniques for all improvement activities, whether JIT, whether TQM, whether TPM, or all Japanese centric strategies, philosophies. 5S is one of the building blocks, one of the foundation member of these philosophies. So, this is based on the Japanese words that begin with S. So, 5 such words are there, 5 such practices are there. Philosophy focus on effective workplace organization, housekeeping and standardized work procedure. It simplifies the work environment, reduces the waste and non-valued added activities while improving quality, efficiency and safety. Once fully implemented, the 5S process can increase morale, create positive impression on customers and increase efficiency of the organization. Not only will employees feel better about where they work, the effect on continuous improvement can lead to less waste, better quality and faster lead time. So, these are some of the advantages of 5S. The first S is SARI, identify unnecessary item which are not required and getting rid of these dead items, non moving items, and whatsoever is left you arrange them in a stratify them, classify them in a nice manner. Third is the Seaton. You should have a functional layout where each item is kept at a place for everything and everything at its place. Very important mantra for housekeeping, place for every item and every item at its place, every item at its place. So, that is the mantra which we can have. Then we are having SASO, workplace and equipment cleaning, to keep the component parts, tools etcetera neat and clean. So, whenever it is required, it is readily available, it is sharpened, it is ready to use condition is there. Then there is a sketch 2, visual management, that means in our case we are keeping cupboards etcetera with doors, wooden doors and other thing, nothing is visible inside. Whereas, in Japanese concepts they keep the cupboards etcetera which is open from all 4 sides. So, that they are visible. So, there is no any unnecessarily component parts are kept, if anything is not required it is taken out from that place. So, that is called a visual control. Then come the Shitsuki, that means this is a habit formation. No manager is going to give ask you to perform these 4 tasks, it is a discipline, self discipline and people are doing as their own personal responsibility. Now, we look at some more techniques. Pokayoke, line stop authority, though I am discussing along with the other areas, nearby suppliers, single sourcing, automation and add-ons. Let us see a brief description of them. This is a Japanese word that means mistake proofing of the equipment or process to make them safe and reliable. Pokayokes are mechanisms used to eliminate error by effectively making it impossible for to make a mistake in a given process. Very important concepts which has a technology, sensors and actuators. When the sensors and actuators, when the right conditions are achieved, sensor will cut off the supply and there is right quality is produced. At the same time, if all conditions are not correct, the machine will not operate. This is good for the safety also, for quality also, various sensors are there. If somebody hand or something is there, machine will not operate. Similarly, if all the conditions are not there, machine will not operate. Let us take one example of a welding shop, spot weld in a car manufacturing unit. You have kept the chassis on a platform and here the jig is there at the top, which has to come down and do, let us say, more than 100 spot welds. And you have kept place all the components which are required on this chassis, and now jig will come and do the 100 plus spot welds. So, that other in the assembly area, then more component and parts are assembled on this attachment. Now, think of if one of the component is missing here, you forget to keep one component, and rather than saying that forget to keep one component, if one component is misaligned by 1 degree only and there are 100 plus components you have kept or 50 plus components you have kept which need to be spot welded. So, what is going to happen to the assembly area? You will not be able to assemble the car. So, what is required, and it is humanly it is not possible. with a production rate of every 2 minutes, every 3 minutes you are producing a car. So, it is not possible. What is required? Poka-yoke is required. You kept the sensors etcetera, unless all the components are there and all the components are at the right place, the jig will not come to do the spot weld. So, that is called the Poka-yoke method, where unless the desired conditions are not prevailing, the process will not be carried out. Second important example which you can connect very easily, filling the air in our tires. What earlier used to be there? There were two nozzles used to be there. One is gauge to measure the pressure and second is to fill the air. So, what happen is here, you fill the air, then check it, fill the air and check it. So, there is a operation and inspection, operation and inspection. What is the new method? Now, you set the pressure on a dial, you say you want a pressure of 35, you set the pressure of 35 on the dial, insert the nozzle, as and when the pressure of 35 is achieved, air supply is going to get cut off. So, that is the kind of Poka-yoke we are having, and all your home appliances etcetera also having a Poka-yoke, where when the desired temperature is achieved, the supply is get cut off. So, that is the concept of Poka-yoke. Then line stop authority I have discussed earlier. So, stop the line authority describes the ability or permission of operator to stop the process when a deviation or problem occurs. By doing so, it is prevented that defective parts are passed on to the downstream processes. So, we have explained earlier. Automation. Automation is not full scale automation, it automates the task that operator would find boring, repetitive or unsafe, but retain human beings to look after the process. Often loading the machine and monitoring of the abnormalities highlighted by the machine, and correction is done by the human beings. Let us see this example. Suppose at a particular station there are two tasks, one is monitoring, second is correction. That means, process keep on working and there is a man who is monitoring whether work is doing right or not. As and when there is a problem, he will come, he will correct it. So, 90% of his time is consumed in monitoring and 10% is in correction. So, cost wise 90% of man cost is for monitoring, 10% is for correction. On the other hand, if we do this monitoring and correction with the help of a machine, with the small sensors we can very easily monitor, but for every fault we need to have a complex mechanism to correct it. So, what we do? We combine the two things. Let the monitoring be done by the machine with the help of sensors and correction is done by the human being. So, what will happen? Sensors will there, they will keep on monitoring, sensor will monitor. If there is any malfunctioning, there is any problem, light signal will glow on the machine will stop and the light signal will glow at that, which is called end-ons. End-ons is nothing but a visual management. Light signal, a tower kind of a thing is there, where a flag is there, different colors lights is there, and depending upon the nature of fault also, the specific color red, blue, green or any such kind of color will glow, and the same signal will be passed on to the will be there in the supervisor area also. So, supervisor will also get to know that on such and such machine such and such problem has occurred. So, the right type of attention is given to that. So, that is called low cost automation or automation. Then we can talk about value stream mapping. In the value stream mapping, as I said, very important concept in IIT manufacturing. Let us see. Value stream mapping is a special type of flow charting, as the mapping is there. So, we are doing the charting, we are mapping the existing flow, existing way of manufacturing to analyze where value or is added or not being added, and as material flow through the process. So, we will see that processes where value is added and the processes where value is not added. It requires a full understanding of the business, including the production processes. Value stream mapping is a two-part process. First part depict the current stage and second part depict the future state. First part we say that this is my current state. So, we construct a value map of the current state, and then we also construct a value map of the desired stage or future stage where we want to be, and then we will develop a road map moving from current state to the future state. So, map of the same process with suggested improvement. The future state map has been annotated using Kaizen burst specific short term project that suggest the areas for improvement. So, our task is to move us the process from current stage to the future state. So, value stream is all actions, value addition and non value addition required to bring a product through the main flow from raw material to final product in the arms of customer. So, this is our flow. So, there are two types of flow, material and information. So, it is a tool that helps to see and understand the flow of material as the product takes its way through the value chain. Information flow is also mapped. The question is, how can we flow information so that one process will make only what the next process needs. So, pull system, it will produce only what the next step is needed and when it is needed. So, that there is no overproduction, there is no early production. So, let us take one example how to draw the current state map. Start with the customer requirements, draw the basic production process with information like cycle time, change over time, work in process between operations, show the material flow arrows, show the information flow arrows. Let us see that value stream map which we have constructed for a particular company. It is a company which is manufacturing automobile component. Raw material is coming from Japan to India, and then there is a, these are your customers for automobile. You are producing some parts, you are ancillary to the automobile sector, and all your Maruti and other companies are your customer. So, there is a marketing department which work out the yearly plans with monthly variations, and this yearly plan is given to the purchase department, and based on that purchase department indebt the steel 3 months in advance. And then the this monthly plans are given to the PPC also for planning of the manufacturing facilities also. So, the material is coming from Japan to India in this way, and then it is kept here at the warehouse. Okay. So, you are keeping 90 days of material here, every 3 months you are placing the order. So, 3 months of material is coming here. Now, this is the various manufacturing stages, manufacturing stage 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, it has 11 is inspection and packing. So, 11 manufacturing stages you are having, and in between the two stages you are keeping the inventory points. So, these are your inventory points between the two stations. So, that all stations are independently planned. So, all stations are planned independently by the PPC department. Okay. So, that is the situation, and then there is a bottom, there are certain numbers, that is how much is the batch size, what is the processing time, cycle time, etcetera are mentioned here. Okay. So, now what happens here? This is the situation, and the total time required to perform the task is 11.4 days, and out of 11.4 days only 12 hours is the value addition time. So, value addition time is, you can say 11 days and roughly 11 hours is the value addition time. So, if it is working in a 3 shift basis, we can say that only 10% is the value addition time. So, let us see what to do in this case. 11 days, let us say if we are working 8 hours per shift. So, 12 into 8, 96, out of that 12 is your productive time. So, we can say that into 100. So, 12.5% is only your value addition time if it is a working of a single shift. So, value addition time is 12.5% and remaining 87.5% is known value addition activities. It is mostly in the form of waiting and transportation. Okay. So, what can be done? Let us see, applying the rules of JIT, philosophy of JIT, let us see what can be done. So, produce to the takt time. Takt time means the cycle time. If there is 480 minutes available and you have to produce 120 components, so takt time is 4 minutes. So, each item should be produced at a cycle time of 4 minutes or a takt time of 4 minutes. Then develop a continuous flow. So, produce to takt time, I have explained that if certain what is the available time per shift and what is the demand for that. This is the example. Suppose this is the components, various components you are manufacturing. Finally, you require after every 60 minutes one component to be manufactured, and if there is a 4 components of a particular type, 4 propellers are required. So, the for propeller the takt time will be 15 minutes. There is 1 unit is required for forward fuselage. So, that takt time is 60. If there are 2 sub assemblies are required, takt time is 30. For each sub 6 components are required. So, takt time of this will be 5 minutes. So, like this. So, we can work out the takt time of all the processes required. Then develop the continuous flow. For the continuous flow, 3 important requirements are: your process should be capable, that means it should produce the right product right every time. If there is it is not capable, if produce the defective items, you cannot have the JIT. Then it should be available also, your maintenance should be perfect, total productive maintenance. TQM stands for total quality management, TPM stands for total productive maintenance. Then it should be adequate also, its capacity should be adequate, right size of tooling. Then we can use the supermarket concept also. What happens, as I said earlier, supermarket concept is items are kept in the shelf, as and when customer is taking the item, the same amount is replenished. You cannot exceed the item more than the size of that particular shelf kept for a particular item. So, that is the supermarket concept. Use supermarket to control production, where continuous flow does not extend upstream. Very fast slow processes need to change over to serve multiple product families. Ancillarized processes, process having too much lead time, unreliable processes, we can use the supermarket concept for that. So, what happens here? There is a process 1, process 2. So, you can have a pull system up to this, and after that the withdrawal is done from here, from the supermarket by the customer, and you are giving the replenishment to the supermarket. Whole JIT concept started with the concept of this supermarket. Then you can follow the FIFO schedule, first in first out in a uniform direction, you can follow the FIFO rule, and there is a concept of pacemaker. If you have seen in the stream value stream mapping, there is a one process which is bottleneck in nature. The output of the line is decided, as we seen earlier also. Suppose there are 10 such kind of a processes, some have 10 minutes of cycle, some have 5 minutes of cycle, some have 15 minutes, 10 minutes, and like that. So, this is called the bottleneck stage, and the speed of the line is going to be decided by this. So, this is called pacemaker. The bottleneck stage in a line is called pacemaker. So, it will decide the speed of the line. So, with this pacemaker, so the JIT philosophy says that there is no need of doing the planning of all these workstation independently. You only plan the pacemaker, and rest of the thing will take care of itself. At whatever you are deciding for the pacemaker, it will pull the material from this side and it will push the material to the other side. So, you plan the pacemaker, and based on the production plan, it will pull the material from the previous workstations. So, that is the concept of it will pull the material from the previous workstation, and there is a push to the other workstations. So, need not to plan all the workstation independently, one station planning is good enough. The process which is scheduled as per the customer requirement, as per the takt time. So, that is the concept of pacemaker, and it is a bottleneck stage. No supermarket downstream of the pacemaker, mostly downstream processes are the pacemaker. As close to the customer as possible, you try to identify the pacemaker, but it is more a bottleneck stage which is a pacemaker. So, you can label the product mix, whatsoever mix you want to produce, you give that direction, you give that planning to the pacemaker process. And you can do the level production also. Hejanka is also followed in that. If the production volumes are not leveled, peak and valleys causes extra burden on machines and people. It is difficult to monitor are we behind or ahead of the schedule. Responding to changes in customer requirement becomes very complicated. So, now we are developing the with this takt time, with the pacemaker, we are developing the future state map. So, what we can do? We can use the cellular manufacturing concept, rather than 2 stages are independent, we can convert it into a cell. and we can eliminate the work in process in between the cell, and one worker can do the both the rail coiling as well as loading unloading on the machine can be done here. So, no inventory or waiting time in between the operations and better utilization of the operator also. And there are several supermarket concepts are there. You can have replenishment pull system, where you hold the finished goods inventory of all products and make to all to stock. There can be sequential pull system, you are not holding any finished good stock and inventory and make all product to order. There can be a mixed pull system, depending upon the situation, depending upon the circumstances, you have to design your pull system. Hold only strangers. In every system there are certain items which are regularly required and there are certain items which are occasionally required. So, they are called, we can divide them into runners which have a fast moving items, there are repeaters which are also having a medium range, and there are strangers which are occasionally required. So, we can hold the runners and repeaters from semi finished supermarket and make strangers to order. So, different strategies can be followed for these components and parts. So, this is how you can classify it based on their quantity requirement per month, runners which are having very high demand, repeaters which are having they are frequently required, but less demand, and strangers which are occasionally required. With this, we are coming to the future state map. So, this is our future state map by incorporating all the improvements which I talked about. So, what we did, rather than planning each process independently, now we are planning only one particular workstation, which is a pacemaker, which is a bottleneck stage. And then we are following the supermarket concept. Based on the production plan of this, the previous workstation will produce according to the pull system coming from the pacemaker. And once it is done, then it will follow a FIFO system, first in first out, or a push system is followed to the next workstation, because we know that the capacity of these workstations is more than the bottleneck stage. So, they are in a position to produce as produced by this pacemaker, and it is able to pull also, because these previous workstation are also having a capacity more than the capacity of a pacemaker. So, this is how we are able to develop the future map, and with this we are finding that from 11 days the lead time is reduced to 5.12 days, and you will find that now the value addition time remains same. Your earlier there was only 10% of value addition time, now it has increased to 20% of value addition time, by reduction in the total lead time from 11.4 days I believe to 5.12 days. So, that is the kind of advantage we can get by following the value stream mapping. So, coming to the conclusion of this JIT philosophy, JIT philosophy is very much matching with the competitive strategy also. The competitive strategy is rapid response to the customer needs, and this is provided with the help of flexibility, with the help of WIP reduction. Then you are competing on the price also, which is coming through the work in process reduction also, inventory reduction also, by increasing the productivity also, space requirement also. Then you are competing on quality, by better quality, by Pokayoke and other quality tools we are improving. And then you can bring the rapid product changes also by lowering the overhead and by bringing the flexibility into the system. So, to conclude, what is JIT manufacturing? What it is a management philosophy and pull system throughout the plant. What it does? It attack the waste, expose the problems and bottleneck, achieve the streamlined production. What it requires? Employees participation, industrial engineering basic, continuing improvement, total quality management and small lot size production, and it expects a very stable demand pattern, very stable demand situation. So, that it is not for innovative product, it is for your regular item which you are manufacturing, especially for coordination between manufacturing unit and the suppliers, vendors. In our situation of outsourcing, where we are outsourcing all the components from the supplier, JIT philosophy work very well for a coordination between manufacturing unit and the ancillaries. Also it worked very well within the plant also to manufacture the item only what is required by the customer when you are producing a large amount of variety, different types of models, they are differing in different specifications as well as in colors and other parts. So, with this we have studied the importance of GIT manufacturing in reducing the inventory requirement. Rather than developing the inventory models to find out how much inventory I should keep, before that we should work on the GIT and try to see that how can I reduce the requirement of the inventory. So, with this we conclude this particular lecture on GIT manufacturing. Thank you very much.